I record it and I put it in my YouTube channel. And the purpose of putting it into the YouTube channel is for you, Aiden, for you, Xingling, for any student that attended my class. If you need to watch it back, you can watch it back again, right? You can watch it back again. So let's continue. Today is physics wave. Step 1, we have 5 drawers. Wait, sorry, I think this one is not the updated one. This is the updated one. Let me just change it. All right. So this one. Right. So we have 5 drawers. Let's make it simpler. Wave, damping and resonance, reflection, refractions, diffractions of the wave, interference and superposition, magnetic wave, electromagnetic wave. Let me say this. Right. So you need to know that we have 5 drawers that we need to fill in the information inside the drawers. So, but for now, at step 1, don't worry about that. Just worry about the story that is helping you to remember the name of each of the drawer, right? If you like, you can write it down in your paper, or you can write it down somewhere, because this story need to stick in your brain, right? Imagine you are the water wave, and now you are damping and resting, right? Then the wave, as you run back, reroute, and diffuse, become Superman that is holding a magnet, right? How do you remember this? Don't just read it. When you're reading this, imagine, put some pictures, put some animations in your mind, how this story is being visualized, right? You are a wave, and then you are now you are damp, whether you are damping as in you're slowing down, or you can think of it as you are wet. Damp is wet, and then you rest, right? How can a wave rest? It doesn't make sense, right? But just imagine that, put some visual imagination of that you are resting, sitting on the couch, but you are the wave, okay? Then what happened? Then you run back. You did a U-turn, you run back on the opposite direction. Then you reroute, you turn left and right, and then you diffuse. Suddenly you are being diffused, and you became a Superman and holding a magnet, right? So this will help you to remember the drawer now, right? Before this story, if I ask you to remember this drawer, this name, it will be very difficult. Now it's becoming easier. You are a wave, you are a water wave. So drawer number 1 is wave, and now you are damp, you are wet, and you are resting. So drawer number 2 is damping and resonant. Third, you run back, reroute, and diffuse. Reflection, right? Reflection, run back, run. Reroute, refractions. Diffuse, diffractions, right? And run back is also, you can associate with reflect, right? You are reflecting, that means like you are reflected, so it's like run back. Reroute, diffracted. I'm not sure whether you understand what is diffractions, the meaning of diffraction, but if you don't worry, you're going to learn it in the following steps. But for now, if you don't understand what is refraction, then just remember it's related to reroute. But if you understood what is refraction, then I think you can associate what reflection with to reroute. Same goes to diffraction and diffuse. right? Become Superman. So superposition. So obviously I took the super to reflect here. Holding magnet. And also obviously I took the magnetic as magnet, electromagnetic wave, right? So even now, without looking into this five drawers name, I think you are able to remember the names. Maybe not 100%, maybe 80%. And we only take less than 5 minutes, right? So you have wave, you have damping and resonance, then you have reflection, refractions, even it's hard for me to pronounce, and diffractions. Then also you have interference and superposition and electromagnetic wave, right? Yes. Yes, one more point. I need to emphasize, I'm not your typical tuition, physics tuition teacher, because I do not teach physics. I'm just maybe 3 days before or 1 week before you, I read this content using the brain drawer method. And now I'm facilitating you to follow these steps, step 1 until step 10, right? And most of the time, by the time you finish step 10, you understood the chapter, right? So we understood the chapter using the method without a tuition teacher. I'm not your tuition teacher. I'm learning together with you. I just learned this maybe few days before you, and I prepare the notes so that we are all able to follow in a very systematic and organized way. That's all I'm doing. I'm not your tuition teacher, right? Now, let's go to step 2. Right, I'll bring this in because it's easier to read like this than on the notes, on the words. I mean, right. So step 2. Let me arrange a bit here. Okay, step 2, if you realize, is designed in a way like the drawers. So you have drawer number 1, which is the wave. Drawer number 2 is the damping and resonance. Drawer number 3 is this reflection, refraction, diffractions. Drawer number 4 is interference and superposition. And drawer number 5 is electromagnetic wave, right? So if you go back to the story, the main story, I hope you write your story somewhere, because we always want to refer to that story. And by referring it frequently, automatically or naturally, that story will stick in your mind, right? So you remember that we are the wave. So wave, and what happened? And you are wet, you are damp and resting, damping and resonant. Then what happened? And you run back, route, and diffuse. So that is reflecting drawer number 3, reflection, refraction, and diffractions. Then what happened? Then once you diffuse, you became Superman. Superman is interference and superposition. Interference, I did not put anything that is related to interference, but I put superposition, right? So at least you know superposition. At least you know there's something related to superposition that's linked to Superman to help you to remember the name of drawer number 4. Then Superman, that is what? That is holding a magnet. So magnet is electromagnetic spectrum, right? So now you're able to remember the drawer in sequence, not in any sequence, all right, in the right sequence. So now let's see. Let's go to drawer number 1, fundamental of wave. So it's wave, right? For now, ignore this first. We will come to this later. So if you can read this, then let me set the clock. Hi. All right. We have to do a bit fast because we spent quite some time on explaining the introduction of brain drawers now. So slightly faster if you don't mind. Okay, just read this in 1 minute. 1, 2, start. 10 seconds. All right. When you read this, I think most of the students will be worried that, oh, I need to memorize this. There's profile, then there's a progressive versus stationary. I need to know what is this. Then I need to know there's a mechanical and electromagnetic. Even the terms is maybe new to you, especially this transverse and longitudinal, right? Don't worry about that. You just need to know that there is this propagation profile and this medium requirement and particle motions. And inside each, there are two different categories that you need to compare. And that's it. If you don't remember the name right now, it's fine because you are still in step 1. Okay. Now let's go for quickly to read. Let's say here, drawer 2, drawer 3, drawer 4 in 1 minute. You can continue to draw 5. We will actually 30 seconds. Ten more seconds. All right. If you are worried and you feel that you do not understand because there are new terms, new concept, new definitions, don't worry too much because you're only in step 2. Right. That is normal. If you can understand, then excellent. Congratulations. All right. So we have 5 drawers, and 5 drawers are talking about the wave, damping and resonance, reflection, refraction, diffractions, interference and superposition, and electromagnetic spectrum. Right. So just have a screenshot of what is the key information messages in each of the drawer. The screenshot now you can take it as, there are classification of wave, and you have this 1, 2, and 3, propagation type, medium requirement, particle motions. And this particle motion is as such. This is the transverse wave. This is the longitudinal wave. So there are 2 different type of wave. And this is the light and water. This is the sound. And this is the frequency. No, sorry. This is the formula. The formula, right? And formula you have. Just remember that there is a formula. You're gonna get more information about this formula in other steps. Then damping and resonance. Damping, there's the definitions, right? Then this refract, refract, and diffract. This is the definition. You just need to understand what is this. The definition of these 3 new terms, if it is a new term for you. Then also, what is interference and what is superposition, right? So you have constructive, destructive, you have coherent sources, then you have the equation also. Then electromagnetic spectrum. Basically, is that 1, 2, 3, 4, 5, 6, 7 spectrum. The 7 frequency that you need to remember. But it's fine if you don't understand fully. If you only understand 30%, that is normal. That is normal. Right. So let's go to step number 3. So how do you read this? It's the same drill. When you read this, remember that, okay, let me just arrange this properly. Remember that it's divided into 5 drawers. So same goes to step 3, it's divided into 5 drawers. And these 5 drawers, if you see this 1.1, 1.2 is associated with here, A and B, right? It's actually 1.1, 1.2, right? The only difference is you're going to have a bit more information. Okay, a bit more information in step number 3 now. So, oops. Where is it? Sorry, I clicked the wrong button. Okay, I hope it's not too small for you to read. If it is, let me know. All right, so let's focus on reading this page in 1 minute. This is drawer 1. Okay, drawer 1. Let's start now. Twenty seconds. Okay, finish. Thumbs up. If you need more time, let me know. Okay, let's do this page from table 3 until wave speed. Let's do 1 minute now. If you realize this wave characteristic is this in step 2. Okay, 30 more seconds. Ten seconds. Thumbs up. Okay, let's do this fundamental wave equations without going to drawer 2 yet for 30 seconds. If you need to read the key wave again, you can do that in 30 seconds. Ten seconds. Okay, time's up. Right. So I need you to have the feeling that we spend this, I don't know, maybe 3 minutes. And now you read back this drawer number 1. You have a better idea, a better understanding compared to just maybe 10 minutes ago when you were reading this step number 2. Right. This Aiden or Singling that was at the level of 2 now became 3. Right. This is how we build. This is how we build knowledge. We don't build knowledge right from 2 straight up to 10. There's no way, because we are human. We take time. Right. We're not AI. So now if you are able to have the feeling that you are from whichever number you were in, let's say 2, right? On the scale of 1 to 10, 1 is the lowest in terms of understanding, 10 is the highest. Let's say you were 2 when you were reading step 2, and now in step 3, you were able to increase to 3 or 2.5 is fine. Right, let's do the same drill for number 2. Right, as long as you have that feeling, and that's fine. That's all I need. Right, the feeling of you improve from 2 to 3. Right, okay. This is drawer number 2. This is the entire of drawer number 2. So let's do 1 minute. Drawer number 2 is straightforward. $30 seconds. $10 seconds. All right, time's up. Now let me repeat the same thing again. Okay, bear with me. I think after reading this part for 1 minute, Singling or Aiden number 2 on drawer 2 now probably become number 3 or even number 4, because this is not something very difficult. This is quite straightforward. And even if you see the notes for step 2, it's only 2 simple lines, right? Now let's continue. So let's continue with the Aiden and Singling number 2 now, right? In the scale of 1 to 10, 1 is the least understood. 10 is you understand very well. So you are now number 3, right? But let me check. Hold on. Okay, so we divided this drawer number 3 into 2 parts. So 3.1 and 3.2. Okay, 3.1 and 3.2. Let's start now. 1 minute. $30 seconds. 30. $10 seconds. 10 seconds. Right, time's up. Okay, let's do the second part of drawer number 3. Right, from phenomena until this communication, long distance communication. Let's start now. $20 seconds. 20. $10 seconds. Okay, time's up. So I hope you feel that now for drawer number 3, you were from number 2, now improve to number 3, right? Let's continue. Draw number 4. Let me see how. Okay, we divided into also two parts. Right. So 4.1 until 4.3. Let's start now. If you have done and you want to continue 4.4, you can do that. Seconds, 20. 10 seconds. All right, time's up. Let's do 4.4 and 4.5 before we move on to the last drawer. Let's start now. Thirty seconds. Ten seconds. Right? The last drawer. Last drawer. Let me see how. Okay. So we divided into two parts also. 5.1 and 5.2. Let's start now. Thirty seconds. Ten seconds. Okay, time's up. If you are attempting or you're worried that you did not, you want to memorize this and you're unable to do that, it's fine. You don't need to memorize that now. I have my story to help you to remember this. Right? For example, red monkey in Vancouver, Ultraman X-ray Gaga. Right? I think you can roughly know what is this representing. Represent these these seven component in the spectrums. Right? We will come to that later in a stage, step 6. So don't worry about too much about memorizing the name. Just know that there are seven components of the spectrum. That's it. Right. Now 5.3 for 1 minute. Start now. Twenty seconds. All right, we completed step 3. There are 10 steps. Now we are in step 3. 30% done. 30% done. And I hope you feel, in terms of feeling, that you felt that Aiden and Singling, that was when you started in step 1, obviously is a number 1, because you know nothing about it. The only thing you know is the drawer and the main story. And when you go to step 2, you know a little bit by reading these keynotes, but you don't feel that you're able to understand fully. Okay, so let's rank yourself as number 2 out of 1 to 10. And when you start reading step number 3, your understanding level increased from 2 to 3. Some even went from 2 to 5, and that is excellent, right? As long as there is some improvement in terms of understanding per drawer, that's what I need you to have to feel, and that's it. Now, let's continue on step number 4. Right, step number 4, there is 8, I think it's 8, yeah, 8 or 10 FAQ. So do the same drill where you need to know which drawer is this. Right, I intentionally make it easier for you. I explain what is drawer number 1, and obviously question 1 and question 2 is under drawer number 1, right? So I want you to constantly relate what you are reading and which drawer it is, because that drawer is your anchoring point. All right, remember the anchoring point. Let's start now for question 1. Let's read from this fundamental of wave motion until itself for 1 minute. Let's start now. Twenty seconds. 10 seconds. All right, time's up. Let's move on to question number 2. I intentionally put it at this part of the screen. So in case you want to read your question 1 later again and you have time, then you can do that. So let's start now, 1 minute for question number 2. Ten seconds. Right? Okay. So I hope now for drawer number 1, your understanding level now increased from 3 to something higher, to a number that is higher. Maybe 3.5, maybe 4, maybe 4.5, or maybe even 6. Right. So for drawer number 1, your understanding compared to 20 minutes ago when you read this step 2 content is better. When you read this step 2, maybe you are at the level of 2. Now, after after doing step 3 and now you're into step 4 and you completed step 4 for drawer number 1, you should go from 2 to something higher, 3 or 4 or 5 or 6, right? As long as you feel that you are improving, and that's all I need. That's all I need. And if you realize this is being designed in a way that it is following the sequence also. Question number 1 is about this part here, right? Question number 2 is about transverse and longitudinal, right? Okay. Now let's go to drawer 2. Drawer 2, let's see how far is it. Okay. The entire page from damping until media. Let's do, okay, let me just scroll up for step 2. Step 2 here on your right is always your reference. Why do I keep displaying step 2 over here? Because I want you to create your anchoring point. So it's easy for you to create anchoring point based on something that is shorter and easy to have a screenshot to see it. Because once you screenshot this question drawer 2, it's only 2 lines. It's only damping and resonance. All right. Okay, let's do this. 1 minute. 1 minute. Start now. Read from damping until media. I think it's a bit too long. I'll give you 1.5 minutes. So don't worry. Okay, it's 10 seconds, but I'm going to extend for another 30 seconds. Okay, let's start again until for another 30 seconds. Ten seconds. Okay, I hope it's enough for you to read this part. So now we are going into question. Oh, now it's drawer 3. Drawer 1, drawer 2, you only have one questions, right? Because I think it's straightforward. Okay, drawer 3, you have I think 2 questions, but let's start with question number 4. Question number 4. Let's start now. 1 minute. Ten seconds. All right, time's up. Let's move on. Question 5, 1 minute. 10 seconds. Okay, time's up. Now, moving into drawer 4. Drawer 4. So let's start. Let me just scroll this up again a bit more here, so you can make this as your reference. Let's start now. Twenty seconds. All right. So by now you should have a bit more understanding about what is constructive interference, destructive interference, that is under the principle of superposition. If you do not fully understand, that is fine. You are still in step 4. But at least you know in the superposition, the principle of superposition, there is something related to two types of interference, constructive and destructive. Even the name itself, it already gives you some idea. What is this interference about? Right. Let's go for question 7, 1 minute. If you need to read question 6 again, let's do that. All right, thumbs up. Last drawer. Last drawer is the electromagnetic wave spectrum. Sorry. Remember in the main story, it is the Superman that is holding the magnet. Superman that's holding the magnet, which is representing the electromagnetic. Let's see how many. Okay, there's only one questions. Let's do 1 minute. Yeah, do the question directly. No need to read the one that's above. Twenty seconds. All right, time's up. Now we have completed step 4. Step 4. And what I want you to feel is you feel that your understanding on this chapter, it was from 1, and now it increased to maybe around 4, right, for each of the drawer. for each of the drawer, right? How do you feel that? Let's now look at these keynotes here on your right. And let's do 1 minute and read it again. And do you feel that, okay, let's read it first. 1 minute, let's start now. I'm going to scroll down as a time to go. Ten more seconds. Okay. Now, we started at 6:11. Now it's less than 1 hour. And I think when we read step 2, it was about 6:20. 6:20 to 7 o'clock is 40 minutes. I think your understanding, you feel that when you were at 6:20, probably at about 1 or 2, the level of 1 or 2. 1 is the lowest, 10 is the highest in terms of understanding. And now at 7 o'clock, when you read this again, there's nothing changed. I did not change anything, a single word in this notes, but you understood it better. Not fully understood, not a fully understanding, but you understand it better from 1 or 2 to maybe 3 or 4. Now let's continue to build on this. Continue to build on this with our step number 5. Right. Now at this point, I need you to know that there are 5 drawers. And these 5 drawers are having different names. How do you remember these names in sequence? Is from the main story. What is the main story? If you jot it down in an A4 paper in front of you, and that is the main story. Right? If you have already written it down in your notes digitally, that is the main story. So what is the main story? The main story is you are the wave, and now you are damp and resting. And then what happened next? You run back, reroute, and diffuse. Suddenly you became Superman or Superwoman and holding a magnet, right? So that silly story, if you can imagine it in your mind, you can create, a visual that is relating to this story, is helping you to be able to remember the drawers, the drawer name. So the drawer name is wave, damping resonance, reflection, refraction, diffractions, superposition, interference, and electromagnetic spectrum, right? So if you realize we are creating anchoring point. Okay, that's why I say anchoring point is important. Now let's continue to move on to step 5 with the objective to move your understanding from 4, if it is 4 now, to 5, right? To 5 to improve it. So let's see how long is this. Okay, we can divide it into 2 parts. So from drawer 1 until this table. Let's do it now. After step 5, we will have a break. Twenty seconds. 20 seconds. All right, time's up. Let's go to the second part of the drawer 1 before we move to drawer 2. Let's start now. Ten more seconds. Okay, time's up. Now I'll repeat the same thing again, the same message. So I hope that you feel your drawer 1 understanding now improve a bit further now, because we have completed step 5, drawer 1. Right. Okay, drawer 2 is so short. Okay, yep, let's do this 1 minute. Thirty second, 30 second. All right, time's up. We are going to drawer 3. Before we go to drawer 3, can I have a thumbs up just to make sure that you're still there? Aiden and Singling. Okay, good. Good. Yeah. The last thing I need is you guys has already dropped, and I'm still talking for another 1 hour to myself. All right. So drawer 3. Now I think now you understand that. Okay, drawer 3. There are 3 parts here, right? Reflection, refraction, and diffraction, and it's all about teaching you or letting you to learn what is this. So you need to know the definition. You need to know the applications. You need to know how it works, and that's it. Very simple, right? So let's start now. Drawer 3. Twenty seconds. 20 seconds. All right. Yep. I'll repeat the same thing again. I hope that you are now increased from Aiden number 4 and Singling number 4 for drawer 3, now towards 5 or 6 or even higher. Okay, drawer number 4 is also rather straightforward, very short. Let's do 1 minute. for drawer number 4? Twenty seconds. Ten seconds. Okay, time's up. All right, the last one, drawer number 5. Let me scroll up a bit here so you can see the chapter, oh no, the step 2. Oops. Let's not do the same mistake again. Okay, let's start now. 1 minute. Drawer number 5. Twenty seconds. All right, time's up. Now, before we go to drawer number, step number 6, no more drawer. Step number 6. I think you have already have quite a good understanding, not full understanding yet, quite a good understanding. What is this chapter about? Now, if someone is asking you, what do you know about the chapter wave? How will you answer them? If I am the student, I'm being asked that way, I'm going to tell, assuming that is the teacher, I'm going to tell the teacher there are components or there are information related to wave, related to damping and resonance, related to reflection, refraction, and diffractions, related to interference and superposition, and related to electromagnetic spectrum. Right. Then from there, I will explain part by part. So let's start with drawer 1. Drawer 1 is wave. Then I'm going to tell my teacher, let's say it's a lady, I'm going to tell her that wave is having for example here, the different classifications. Then there is a propagation profile, medium, and particles. Then I'm going to talk about the progressive versus stationary, mechanical versus electromagnetic, the transverse versus longitudinal. Right. If I want to be more, explain about the equations, then I can talk about the equations. V equivalent to F lambda. Right. Then damping. I can talk about what is damping, what is resonance. By now, I think you have some idea and you can explain it well, what is damping and what is resonance. Then the next drawer, reflection, refraction, diffraction. Also, I think by now you have some idea, maybe not a full understanding, but some idea, especially what is reflection, because reflection is something you experience it almost every day. Right. Then what is refraction and what is diffractions? Then you can talk about the superpositions, talk about the constructive and destructive interference, talk about what is coherent sources, what is this interference equations. Okay. Then talk about the electromagnetic spectrum. There are 7 of them. All right. So that is why our brain needs anchoring point. Once we are able to anchor, then we will be able to retrieve the right information from the drawer that was being created 1 hour ago. Right, now it's 7:13. We did it. We created a drawer 6:11. Right, 1 hour ago. We created that drawer, and then we built more information. We put more items. Let's put it that way, inside each of your drawer. Right. So now, with that, we are moving into step 6. Step 6 is create stories. Right, create stories. So let's see, what is this very silly and funny story? That doesn't make sense story. Papa play PS. PS is PlayStation. Mommy, me, and Popo. This is a Chinese. Tao lan. In Cantonese is Tao lan. That means being lazy. Right? Then there's another, the ATV. ATV is like a vehicle, all-terrain vehicle. I draw it this way. Fly. Right. So if you go into the drawing, you have Papa playing PS, the PlayStation. Mommy, me, and Popo, we are lazy. We are Taulan. Taulan. Okay, Taulan is Cantonese. Taulan is Chinese. Then ATV, fly. So what does it represent? I think from this story, you have a rough idea already by now. You should have a rough idea by now. What is this representing? Propagation is Papa. PlayStation. So Papa is playing PlayStation. Progressive and stationary. P, stationary, S. So PlayStation. So it reminds us of there's a propagation model, and then there is a progressive wave, and there is a stationary wave. Right. Then Mommy, me, and Popo, Tolan. Right. Medium, I represent Mommy. Me is mechanical and electromagnetic. So me, ME. Popo is particle. And then Tolan is transverse and longitudinal. Right. So now this very short story, if you can imagine it, picture it in your mind, you can do the animation by yourself. Your papa is playing a PlayStation, so happily playing over there. And your mommy, and next to you, and next to your mommy is yourself, me, and my popo. We are all being lazy, Tolan. Right. So that story itself is already able to help you to remember these classifications of wave. Okay. Then ATV fly. What does it mean? Here, A is the amplitude, T is the time, I think. Let me see. Right, the period. Okay. F is the frequency, lambda is the wavelength, V is the speed. So how do I remember these key wave characteristics? So I remember it by there's an ATV, all-terrain vehicle, fly. Okay. So from there, you're able to remember these are key wave characteristics. ATV, so I move the V into the position number 3, so I can combine it as ATV, fly, FL, L is for lambda, then the Y is just to make, just to be able to form the word fly. If not, then it's ATV, FL. All right, so that is the purpose of this story. Now, story number 2 is damp and resting. So damp, I think by now you know what is this. And resonant. So damping and resonant. Drawer number 3 is, the story is Wendy, Fred, and Vera turn back, and then only if Fred stops, the rest are still moving. Wendy and Vera are still moving, are still walking. And then suddenly all stop at a narrow route. Okay, so what does it mean? Wendy, Fred, Vera represents the wavelength, frequency, and velocity. Wendy, wavelength. F, frequency, Fred. Velocity is Vera. Why turn back? Turn back is representing reflection. Okay, so in reflection, Wendy, Fred, and Vera, they are unchanged. Only the direction changed. So that's why turn back. And then what happened? Then only Fred stopped. The rest did not stop. They continue walking. So this is to explain refraction. Why refraction is related to Fred not stop. Fred stop. Frequency unchanged. During refraction, frequency did not change. Right. Only Wendy and Vera changed. Right. Change means moving. For my case, okay, my story, I did it that way. Okay, unchanged means stop. That's my reason. So you see, this part is to explain refractions, and it's talking about frequency unchanged during refractions. Okay. Then the third one, all stop at narrow route. So it's about diffractions. Diffractions is similar to reflection. Everything is unchanged for these 3 key factors. They are unchanged. But there's something that you need to know. Narrow. It spreads or it diffracts more when the slit is narrow. Okay? It diffracts more when the slit is narrow. So that is the story to help you to remember the content of this drawer number 3. Reflection, refraction, and diffraction. Now let's move to, I hope everyone is following, right? If not, don't worry, you still can watch the video again, or ask me any question later, right? Now, drawer 4, 2 Superman, friend and enemy from the same source. I think this also is quite explanatory by itself. This story is helping you to remember that, okay, there is this 2 is related to superposition because it's Superman. Then 2 Superman, sometimes they become friend, sometimes they become enemy. Sometimes they are so good, like a good best friend. Sometimes they fight with each other and they become enemy. So this is to explain constructive and destructive of 2 waves, right? Then coherent sources is the same source. They came from the same source, right? Whether they came from the same mummy or they came from the same planet, right? Coherent source. So what is coherent source? Right, having the identical frequency and constant phase difference, right? Last story, this is easy. This is to help you to remember the 7 electromagnetic spectrum. Red monkey in Vancouver, Ultraman X-ray Gaga, right? Or you can put red monkey in a van, because Vancouver is very hard for me to draw. I don't know how to draw Vancouver, so I draw it as a van. Then Ultraman X-ray Gaga. Gaga. I'm not sure whether you know Lady Gaga. Yeah, I took the Gaga from Lady Gaga. So Lady Gaga always wear something very weird. So So this is representing Lady Gaga. All right. So the story. So they are completed, the story and also the drawing. All right. Two Superman, sometimes they are friends, sometimes they are enemy. And they come from the same source. Wendy, Fred, and Vera, they turn back. Then for the number 2, Fred stop. These two guys are still moving. Then number 3, all of them stop at the very narrow route. Okay, so these are the stories. Remember, these stories are important. Why important? Before we start the class, I told you why is it important. Yeah, I already told you, right? So the important thing is for you to have an anchoring point. So these stories is to create anchoring point for the drawers. Then the main story, which is not this story, the main story is to create the anchoring for you to remember the drawer name. So you have the anchoring point on the drawer name. I hope everyone is still following, right? Are you guys still following? Give me a thumbs up. Good, good, good. Right. Now, without further ado, let's move to step 7. I think by now your understanding about this chapter should go a bit more higher, right? A bit more higher, right? I'm expecting you to somehow write this or screenshot or whichever that makes sense to you, or even if, and also the drawing, either you draw it by yourself quickly or you screenshot it uh, to prepare yourself on the revision steps, right? Remember the revision step that I talked about before the class, the 10-minute revision steps, right? So this is going to help you in the revision step to maintain you at the level 9. Now you're not in level 9 now. You're going to be in level 9 very soon, right? And you don't want to lose that level 9. You don't want to go down to level 5 or level 7 or even level 8, right? How do you do that? You need to do revision. And this revision is not, we're not talking about 2 hours revision. We're talking about only 10 minutes or even less. Now, with that in mind, let's move to step number 7, answer quiz. Right. So how do you do this? Read the questions, and then with the drawing and the story that is next to you. Okay, I hope you have already have this somewhere written or screenshots, right? If not, then hope that you can memorize and remember all this if you are super genius, right? Now, when I read this question, so how do we do this? When I read this question, then I ask myself, which drawer is this? In fact, I already gave you the answer. It's drawer number 1. Then how do I answer these questions? I do not read the answer yet. I create some answers from the understanding so far that I have. Right? It doesn't need to be a very nicely created sentence or paragraph, just some keywords. Once that is being formed, then you read the answer that is given. Whether your answer and this answer are the same. If not, this is where the discovery starts. You discover something new that was not in your knowledge base, that you do not know yet, and intentionally pick that new information and put it inside drawer number 1. Right? This is drawer number 1. All right. Let's not talk too much for me. Let's start the exercise. Let's do the first question a bit longer for 1 minute. Okay. Let's read it and do the thing that I told you just now. Read it and then form your own answer. Then read the answer and do the discovery. 10 more seconds for question one. Question one is it's a bit long, I think, the time given. But it's good for you to refresh what you need to do. Right now, we'll do 2 questions in 1 minute, since now you have already warm up, right? So what you need to do is read the questions, form your own answer, whichever answer it is. It could be wrong answer, it could be right answer, doesn't matter. The objective is not for you to make sure that you are having a perfect answer. No. The objective is to help you to train your retrieval skill. Retrieve your information, how fast you can retrieve the information from your database, from your knowledge base. Right. Once you have done that, then only you read the answer and do the discovery stage. Right? So let's do question 2 and question 3 in 1 minute. Start now. Okay. Now we are going to question 4. Question 4 and 5. Let's start now. Question 4 and 5. Ten seconds. Okay. Question 6 and 7. They are still drawer number 3. Let's start now. Oh, I've forgotten the break. Okay, after this we have a break. So sorry, so sorry. We have 10 questions. 10 seconds. Okay, 8, 9, and 10. Let's do it in 1 minute. Then we have a break. So sorry. Okay, let's have a break of 5 minutes. Let's go for a water break or toilet break. Let's start now. See you later. I'm back. We have 40 more seconds. Are you guys back? Can I have a show of hand? Yes, Aiden is back. All right. Okay, let's rest for another 20 seconds. The hardest part are all done. The next one is the easier one. All right. Let's change this back. I think we don't need timer anymore. Let's keep it somewhere. Okay. Now, the easier one, watch video. Click this. Okay, let me share. I'll share again the screen.
Literally everywhere. The music you're listening to.
Can you hear him? Can you hear?
The light from your screen, the Wi-Fi
Yes.
that's bringing this to you
Aiden?
right now. It's all just energy moving in waves. You could say they're the basic language of the universe.
Okay, good. Now let's start again. So it's only 8 minutes. Yeah, remember the drawers, because the video is being designed intentionally based on the drawer in sequence, right? And also remember the story of the drawers. So that will help you to remember what is inside the drawer. Right, let's start now. Enjoy.
You know, waves are quite literally everywhere. The music you're listening to, the light from your screen, the Wi-Fi that's bringing this to you right now, it's all just energy moving in waves. You could say they're the basic language of the universe, and today we're going to learn how to speak it.
Have you ever been in a really nice concert hall and wondered, how does the sound get to be just perfect from every single seat? Well, take the Petronas Philharmonic Hall. It's an absolute masterpiece of acoustics, and it's all about controlling sound waves. They have these special moving ceilings and walls that don't just trap the sound. No, they shape it. They reflect it, creating this incredible listening experience. That, right there, is the power of understanding waves.
So here's our roadmap. First, we'll cover the absolute basics. What even is a wave? Then we'll get into damping and resonance, basically how waves live and die. After that, we'll see what happens when waves bounce and bend, and what happens when they run into each other. And finally, we'll zoom way out to look at the whole electromagnetic spectrum.
All right, let's dive right in. First up, what is a wave? Really, at its core, it's all about energy on the move.
Okay, this is probably the most important thing to get. A wave moves energy, not stuff. Think about it like this. Imagine you have a long slinky, and you tie a little ribbon to one of the coils in the middle. If you whip one end to send a pulse down the spring, that wave travels all the way to the other side, right? But what about the ribbon? It just bobs up and down in the same spot. The energy moved, but the matter, the ribbon, stayed put. That's the whole game.
Now, waves pretty much come in two main flavors. First, you've got transverse waves. Think light or ripples on a pond. The particles themselves move up and down at a right angle to the direction the wave is actually traveling. That's what gives you those classic peaks and troughs. Then you have longitudinal waves, like sound. With these, the particles vibrate back and forth in the same direction as the wave. This creates spots where the particles are all bunched up, we call those compressions, and spots where they're spread out, which are rarefactions.
And to really talk about waves like a pro, we need three key terms. First is amplitude. That's just how much energy the wave has. Think of it as the height of an ocean wave. A bigger wave has more amplitude. Then there's wavelength. That's the distance from the top of one wave to the top of the very next one. And finally, frequency. That's how many full waves pass by a single point every second. A high-frequency wave is like a bunch of ripples, one right after the other.
Okay, let's talk about the life and death of a wave. We're going to look at two opposite forces, damping, which makes waves fade away, and resonance, which can amplify them to incredible, sometimes even dangerous levels.
You ever pluck a guitar string and wonder why the sound eventually fades out? Or why a pendulum in a clock will eventually stop swinging if you don't wind it? Well, the answer is damping. It's just the natural loss of energy over time, usually because of things like friction or air resistance. This makes the wave's amplitude get smaller and smaller until, poof, it's gone.
So what happens if, instead of letting a wave lose energy, you start adding it at just the right time? Well, that's resonance. It is exactly like pushing someone on a swing. You don't just shove them whenever, you time your push to match the rhythm of the swing. When you do that, they go higher and higher. You're matching the swing's natural frequency, pumping energy into the system and making its amplitude grow a lot.
And this is probably the most famous and frankly terrifying example of resonance. The Tacoma Narrows Bridge didn't collapse because the wind was too strong. It collapsed because the wind was just right. The wind blew in these steady gusts that happened to perfectly match the bridge's natural frequency of twisting. This resonance pumped more and more energy into the bridge, causing it to oscillate so violently that the structure literally ripped itself apart. Just an incredible amount of power.
So, we know waves can fade out or get supercharged, but what happens when they actually hit something? Well, in this next part, we're going to look at how waves bounce, bend, and spread out as they move through the world.
The most straightforward interaction is reflection. The wave just bounces. It's like throwing a ball against a wall. The angle it comes in at is the same angle it bounces off at. Simple. The wave changes direction, but its speed and frequency stay exactly the same. This is precisely how sonar technology works. It sends out sound waves and just listens for the echoes, the reflections, to map out what's on the bottom of the ocean.
Okay, next up is refraction. This is what happens when a wave bends, and it happens anytime a wave changes speed, usually when it moves from one medium into another. Here's a really cool everyday example. Sound actually travels faster in warm air than in cold air. So, on a clear, cool night, the air near the ground is colder than the air above it. Sound waves from far away will actually bend downwards toward that colder ground, which is why you can sometimes hear conversations from super far away with amazing clarity at night.
And finally, we've got diffraction. This is the tendency of waves to spread out as they pass around an obstacle or through a gap. You know how you can hear someone talking around a corner even before you can see them? That's diffraction in action. The sound waves are literally bending around that corner to reach your ears.
All right, so we've seen how one wave behaves, but our universe is a crowded place. What happens when two or more waves show up in the same place at the same time? Let's talk about the super cool world of interference.
The rule that governs these wave collisions has this really fancy name, the principle of superposition. But the idea is so simple. Wherever the waves overlap, you just add their amplitudes together. That's it. It's just simple addition.
And that simple math gives us two totally opposite results. If the peak or crest of one wave meets the crest of another, they add together to make an even bigger crest. We call that constructive interference. But what if the crest of one wave meets the trough, the low point of another wave? Well, if they're the same size, it's like adding +1 and -1. You get 0. They completely cancel each other out. And that is destructive interference. And this isn't some abstract concept. You use it all the time. This is the magic behind noise-canceling headphones. What are they actually doing? Well, there's a tiny microphone on the outside that listens to the noise around you. Then, the electronics inside instantly create the exact opposite sound wave, a perfect anti-noise wave. When that outside noise and the new anti-noise wave meet inside your ear, they destructively interfere. They cancel out, and all you're left with is silence. It's literally creating silence out of sound. How cool is that? Okay, for our last section, we are zooming all the way out. We're going to move beyond the waves we can see and hear and explore the huge invisible rainbow that is the electromagnetic spectrum.
You know, our understanding of all this didn't happen overnight. It was this giant puzzle put together over almost 100 years. It really kicked off in 1801, when a guy named Thomas Young proved that light actually behaves like a wave. Then, fast forward a few decades, and the absolute genius, James Clerk Maxwell, comes up with this wild theory that light is just one type of electromagnetic wave. And finally, in 1887, Heinrich Hertz actually proves Maxwell right by generating the very first radio waves.
And once Hertz did that, the floodgates opened. We discovered this whole continuous range of energy, the full electromagnetic spectrum. At one end, with the highest energy and shortest wavelength, you have gamma rays and X-rays. Then comes ultraviolet, and right after that, this teeny tiny little slice that our eyes can actually detect, visible light. After that, we go to infrared, microwaves, and finally, the longest, lowest energy waves, radio waves.
And we have put this invisible world to work in almost every part of our lives. Radio waves give us our Wi-Fi and broadcast TV. Microwaves cook our food and carry our cell phone calls. Infrared is in every remote control. X-rays let doctors see right inside us. I mean, our entire modern society is built on our ability to control these invisible waves.
So what's the one thing that connects this whole diverse family of waves? It's their speed. In the vacuum of space, every single one of them, from a gamma ray to a radio wave, travels at the exact same unbelievable speed, 300 million meters per second, the speed of light. It's the cosmic speed limit. Nothing goes faster. So there you have it. From the perfectly sculpted sound in a concert hall to the invisible Wi-Fi signal hitting your device right now, waves are the invisible architects of our world. They are energy in motion, constantly bouncing, bending, and colliding all around us. So the next time you use your microwave or change the channel with a remote, take a second to think about that invisible wave doing the work and the incredible world it belongs to.
All right, thank you. This is, wait, let me just, okay, move this out. Yep. So step 8 is done. Step 8 is done. Now, we have step 9. So I believe by now, your understanding that was about 1.5 hours ago at 1 or 2, when you start reading this for the first time, now it increased to definitely a level that is much higher. What is the level? Only you will be able to tell yourself. Whether it's 6, 7, 8, or 9, or 11, if it makes sense, 11. Yeah, we will be able to test that after step 9. So let's continue to increase the level as much as you can by podcast, by listening to the podcast. How do you listen to this podcast? It's the same way. Focus on the drawers and then focus on the story inside the drawers that is related to what the podcast guys is talking about. Okay, let me just open the podcast.
You're at a stadium, right? Tens of thousands of people.
Okay, it's only about 6 minutes. So let's do this. Let's do this. When the podcast is talking about certain parts in the keynotes, I will highlight. Let's start now.
You're at a stadium, right? Tens of thousands of people.
And suddenly the Mexican wave starts.
Exactly. You stand up, you throw your arms up, and sit back down. You haven't actually moved from your seat.
But that ripple, that energy, it just traveled the whole arena.
It's the perfect visual for our deep dive today. We're unpacking a really fascinating physics chapter about how unseen energy travels through our world.
Yeah, because what traveled wasn't matter. It was kinetic energy.
Right. So let's get right into the mechanics. The textbook starts with damping, which is just systems naturally losing energy to friction, right?
Yeah, or air resistance. Over time, they just kind of slow down.
But the opposite scenario is what really caught my eye. Like, what happens when you feed energy into a system at its natural frequency?
Ah, resonance.
Yeah, resonance. And you usually think of that for, like, tuning a guitar or a piano, right?
Well, sure, but the physics actually highlight a completely different and much more destructive structural side to it.
Like, destructive.
Oh, yeah. If a periodic force perfectly matches an object's natural frequency, the amplitude of the vibration grows exponentially. Energy is being added way faster than damping can, dissipate it.
Which is exactly what happened with the famous 1940 Tacoma Narrows Bridge collapse.
Exactly.
I mean, the wind didn't just blow it over. The wind's aerodynamic flutter matched the bridge's natural frequency.
Right. It pushed it higher and higher, like pushing a kid on a swing at exactly the right moment.
Until the steel literally just tore itself apart.
Yeah. And even the London Millennium Footbridge suffered a milder version of this. Just 2,000 pedestrians walking in synchronous step accidentally fed energy right into the bridge's natural sway.
Making it dangerously unstable.
Exactly. So resonance dictates how structures absorb wave energy. But before a wave even reaches its target, it has to, navigate the environment.
Right, like bouncing, like high-frequency ultrasound waves reflecting off internal organs to create a medical image.
Yes, reflection. But there's also refraction, which is how waves bend when they change speed.
That part completely reframed quiet nights for me.
Oh, the temperature differential.
Yeah, because sound travels faster in hot air, right?
It does. I mean, during the day, the hot air near the ground bends sound waves upward.
Kind of away from you.
Right.
Yeah.
But at night, the ground cools the air down, so that cooler layer acts almost like a lens.
Bending distant sounds downward, right towards your ears. It's wild.
It really is. And if waves aren't bouncing or bending, they're spreading out through this process called diffraction.
The example that blew my mind here was the elephants.
Oh, the infrasonic communication?
Yeah, they communicate over massive distances using infrasonic sound, like super low frequencies.
Well, the mechanism there is brilliant. For a wave to diffract or bend around an obstacle, its wavelength has to be comparable to or larger than the obstacle itself.
So high-pitched sounds with tiny wavelengths, they just hit a tree and scatter.
Right, but infrasonic waves have these massive wavelengths, dozens of feet long.
So they just wrap right around tree trunks and hills as if they aren't even there.
Precisely. Now, all these behaviors, bouncing, bending, wrapping mean waves, are constantly crashing into each other.
Right. And when they overlap in the same space, we get superposition, where they literally add together.
Yeah, so constructive interference gives you a bigger wave.
But destructive interference is where it gets highly practical.
Hmm.
Think of two people trying to push a swing, right? If one pushes forward exactly when the other pushes backward,
The forces cancel out entirely, the swing stays perfectly still.
which is exactly the physical mechanism inside your noise-canceling headphones.
Yes. A microphone reads the incoming sound wave from the airplane cabin, and a speaker generates an identical wave perfectly out of sync. It pushes when the cabin noise pulls.
Leaving you with zero sound. And shipbuilders use the exact, which I had no idea about.
Oh, right, the bulbous bows.
Yeah, modern ships have those strange bows jutting out underwater. They generate an artificial wave specifically timed to destructively interfere with the ocean's natural drag wave.
Canceling it out and saving massive amounts of fuel.
So cool. But up to this point, we've only discussed mechanical waves, sound, water.
Things that require a physical medium, yeah? Like air or steel to travel through.
But the electromagnetic spectrum totally breaks that rule. I mean, radio waves, visible light, X-rays, they don't need a medium.
Right. They're essentially oscillating electric and magnetic fields playing leapfrog, meaning they can travel through the absolute vacuum of space.
Which is why sunlight actually reaches us.
Exactly. And for a long time, the scientific community fiercely debated whether light was a physical particle or a wave.
Until Thomas Young's famous double-slit experiment. He shone light through two narrow parallel slits.
And if light were just particles, you'd expect to see just two distinct bright lines on the wall behind them.
But instead, he saw a whole pattern of alternating bright and dark bands.
The dark bands were the smoking gun. It proved that light waves spreading from the two slits were overlapping and destructively interfering.
Canceling each other out to create literal darkness. I mean, light behaves exactly like water in a harbor.
It's all the same underlying physics.
It really is. So what does this mean for you? Well, whether you're clicking a TV remote using infrared or just listening to a quiet night.
You are swimming in a vast, invisible sea of wave physics.
Energy, just moving through the stadium of your life. Which leaves us with a really interesting thought to ponder.
Oh, what's that?
Well, since all electromagnetic waves can interfere with one another, just think about the sheer volume of invisible, silent wave collisions happening right inside the room you're sitting in at this exact moment.
All right, interesting. So now we have done to step 9, almost completed. Now let's go to the FAQ, not FAQ, the MCQ. Where is this? Okay, let me just open this again. ChatGPT. I uploaded this morning. This one, yeah. So like what I always do, I uploaded the textbook into ChatGPT and asked ChatGPT to give me, ask me 10 MCQ one by one without answer. If I got it wrong, explain the right answer. Okay, let's do it now. All right, remember that you have your drawings and your drawing next to you. Right. What is the drawing? The drawing is this one. Remember that you have your drawing next to you. Imagine that you are now in your exam hall and you are about to answer 10 questions in this exam, and this drawing is next to you. Let's see whether this drawing is going to help you. Okay. I need you guys to help me by answering this. So you know the format. You give me which questions, which drawer, and which answer. Let's start now. Okay. Ask me 2 MCQ at a time. Right, let's do it. What's the answer for number 1? Which quantity represents the distance between two consecutive points in phase? Which statement about transverse wave is correct? I think you don't need to mention about which drawer because it's there already. It's drawer number 1. Just tell me which question, which answer. Like I always say, don't worry about getting the right answer. Just try. Even if it's wrong, it's fine. Okay, question 2, drawer 1, answer B. Okay, what about question 1? And what about Xingling? To B. 1. One C. What about Aiden? Distance between two. Okay, let's try. Correct. Congratulations. Like I said, I'm not your teacher. I'm also learning together with you. I also think it's these two answers. Right. Okay, let's do number 3 and number 4. Okay, number 3 is drawer 1, number 4 is drawer 2. On your right hand side is the drawing for your reference. Any idea? 3 and 4. 4 is C for Aiden. What about 3 and also Xingling? What about 3 and 4? Number 3, if I remember correctly, the answer is B. B and C. Okay, I think both of you have the same answer. I also have the same answer. Perfect again. Great. Okay, number 5 and number 6. Resonance occurs when each quantity does not change when a wave is reflected. Which quantity does not change when the wave is reflected. You remember this story? Drawer number 3, Wendy, Fred, and Vera. This is talking about reflection. I have my answer. I'll wait for yours. C and B for Xingling. Question 5C. What about 6? I think everyone agreed that it is C for 5. Also B? Okay, let's try. Me too. All right. Question 7 and 8. So far, we are doing very well. Refraction. Okay, drawer 3. Drawer 3, the second part. When a wave move from deep water to shallow water, what happened? What happened to refraction? Refraction, remember? Fred stopped. So Fred did not change. B and C, Aiden. Also singing. I think it's B and also think it's C. No, is most noticeable when wavelength is comparable to a larger than gap. Okay, let's see. Well, I think we are doing well. Last set, 9 and 10. Come on. Very exciting to see if we are gonna get this right again. When two waves meet and produce a large amplitude, it is called. Okay, 10 is C. Which statement about electromagnetic is correct? Okay, you're right. I think so. Number 9? What is number 9? Number 9 is C. All right, I think so too. Congratulations. So what does it mean? It means that you move from 1 when we were at 6:11. That was less than almost 2 hours. And now you move to at this MCQ, if you do it as the assessment, you are 10 out of 10. So how do you maintain you are always at this level? Right, you have to do revision, and that revision is the step that I told you a while ago. These steps, right? These steps. So you need to remember the main story. You need to remember the drawer story, right? And that needs frequency. That needs you to have a consistent and frequently doing this 10 minutes, right? I can only come to this stage to teach you and to tell you what are the steps to help you to do revision. But I will not be able to be next to you every day for 10 minutes to run this revision with you. So it's your decision, right? So I think congratulations. Thank you very much for these 2 hours. And I hope you learned something new today again. Hope to see you next week. All right. Oh, yes. One more point. Sorry. One more point. This MCQ, to be honest, is not it's not hard questions like what you're going to get in your exam. So you need to be exam ready. How to be exam ready is you need to do more, let's say, past year questions, or do more exercise, or do more readings to help you to become exam ready. What you are doing right now in these 2 hours, in this short period, these 2 hours, is to build the foundation. Once you have the foundation in understanding this chapter, then it's easier for you to build more understanding and deeper understanding as you progress to prepare for yourself for the exam, or for you to be a physicist. All right. Thank you very much. Hope to see you soon. Bye-bye. Hope to see you soon. Yes. Hi. Thank you. Welcome. Yes, Singling. See you soon. Okay. I will. You too have a good weekend. I will leave now and have a good weekend. Bye-bye.